Hello guys, CoffeeJUG is back. Last time we had some troubles with internet connection. Today everything should be fine. We hope so. Finger crossed. Also today we're happy to see Łukasz from Poland with talk M3 and Prometheus. So welcome. In community we trust. This is our domain driver. And we already have the 20 events and more than 500 unique participants. Let me introduce our organizers. It's Andriy, Ira, and Igor, and also our program commit members, Olesa and me. These people care about the quality of presentations on CoffeeJUG. Also, many thanks to our Awenga, Sombra, and Grid Dynamics partners. These guys supports our community here in Lviv. Also, we have an activity bonus. So, guys, for the best question to our speaker, we will send you bulочка и cacao to the most active persons. So, guys, join us. Follow us in Facebook, Twitter, or the Telegram channel. Yes, right now we will switch to our main screen, and then we will prepare the main talk and switch back to you.
Hello everyone, my name is Łukasz Szczęsny and I'm here to talk to you about M3 and Prometheus and monitoring at scale for everyone. Hello everyone. My name is Łukasz Szczęsny. I work as a software engineer at Chronosphere. At Chronosphere, we are building a scalable, reliable, and customizable monitoring as a service solution which is purpose-built for cloud-native applications. And our core of our product is M3DB, which I will be talking about today. Previously, I used to work as an infrastructure head at a Polish startup called Deskiller. And prior to that, I used to work as a software engineer at Uber, where I started my journey in observability team at Uber in Vilnius. There's my Twitter handle and my email address. If you have any questions and we won't be able to answer them on this call, just feel free to drop me a note. If you'd like to know about Chronosphere, learn more about Chronosphere, also feel free to reach out to me. Okay, so let's jump to the agenda today. First, we're gonna talk a bit about monitoring with Prometheus, what it does, what is Prometheus, what it does, and what are the pain points of running Prometheus. And then we're gonna switch to subject to monitoring with Prometheus and M3. I have a super short demo for you as well. Hopefully the demo gods will be willing to let our demo work today, and then we will have some time for Q&A, hopefully. Okay, so let's jump straight to monitoring with Prometheus. So Prometheus is an open source monitoring and alerting toolkit written in Go. Is basically a single binary which has all batteries included. It was inspired by Google's Borgmon monitoring system. And it started at SoundCloud in 2012, then it joined Cloud Native Computing Foundation in 2016. It's already a graduate and it's kind of a go-to monitoring tool for cloud-native applications and cloud-native world. Let's talk about few key features of Prometheus. If you ever used a monitoring system like Graphite or StatsD maybe or something like that, you probably will be a bit surprised how Prometheus is doing the metric scraping and so on. But let's start with the data model. Prometheus has multi-dimensional data model where every time series data is identified by a metric name and a set of unsorted key value pairs. So we have like a metric name, and in brackets you have like label name, label value, comma, label name, label value, and so on and so forth. So the difference I mentioned before is that Prometheus is scrape-based metric ingestion, has scrape-based metric ingestion, which means it's pulling time series data via HTTP server. So for example, if you running your application need to have HTTP server which exposes metrics. Prometheus goes to this endpoint, downloads the metrics, and stores it into the time series database. So this is like super, sometimes it could be a bit strange at the beginning. But also when you have an application which can only push time series, for example, long, like short-lived cron jobs or bad jobs, it's still possible to push the metrics via intermediary gateway. Prometheus has an efficient storage engine, and the killer feature from personally for me is PromQL. It's like super flexible query language to query all time series data which are stored in Prometheus. The PromQL you use in alerting, in querying, also in recording rules. Well, you can do aggregation in Prometheus. So for example, if you'd like to calculate averages of some metrics and write this as a time series database, you can do it in Prometheus as well. So let's jump from the king concept to the architecture diagram overview of Prometheus. I a bit lied to you about like single binary. It has more binaries, but like the main binary in the middle is Prometheus server. It's responsible for retrieval. So this is the thing which scrapes metrics. It's responsible for storing the metrics in time series database in TSDB, and it also have a query part which like exposed from Prometheus itself as well. So what are the advantages of Prometheus? So actually, it's super easy to get started with Prometheus. As I mentioned, it's a single binary for ingestion, storage, and query. If you need to add alerting, it's another binary. It's a CNCF recommended monitoring tool. And kinda its exposition format of metrics is widely accepted. And it's supported by many applications. For example, if you run Kubernetes exposes metrics in Prometheus format. Same for etcd and a lot of cloud-native projects, CNCF projects. It has dynamic endpoint discovery on many platforms. So basically, if you running, for example, your production application on Kubernetes, and you would like to monitor all the pods of the applications, you just like install Prometheus, add special annotation, Prometheus will discover all the pods and will start scraping metrics right away. And you can be able to query those metrics and alert all those metrics. Another thing which is like worth mentioning here is ecosystem of exporters in Prometheus. In most cases, for example, when you write Java, you just like add micrometer as your dependency and start HTTP server, and you expose all the metrics. And it's like super easy to go. If you, for example, having a Spring Boot application, you can super easily expose all the metrics from JVM, from HTTP server, and everything else, and adding custom metrics, for example. But in some systems where you cannot modify your code, like some obscure applications from 10 years ago or a database, you probably will have to write a simple binary which will connect to this application or database, query the state of the application or the database, and it expose in Prometheus format. Then Prometheus will scrape those metrics and store them in TSDB. So when we described how Prometheus works and what are the advantages of Prometheus, let's see how we can install Prometheus. So basically, Prometheus, you just download a binary or whatever, start a single binary, Prometheus, start another binary for Alert Manager if you need alerts, and then you start Grafana to have a really nice dashboarding solution. And you configure Prometheus to scrape metrics from your services. Here we're scraping the service A, service B, service C. So we have our monitoring solution running, and we are super happy about it until Prometheus fails. So probably you won't even notice that this Prometheus failed, as you probably not monitoring your monitoring when you have single instance of Prometheus, which brings us to the subject of Prometheus reliability. So we just we start to worry about it when we finally coming out from testing Prometheus in like test environments with single Prometheus, and we moving to the production, we have to make it reliable. So the recommended solution for Prometheus would be just run 2 instances of Prometheus, which would scrape all the targets. Both of them will scrape all the services for the metric, so would have metrics in both Prometheuses. So if one Prometheus goes down, you can still have a copy of your metrics while this Prometheus is down. When it comes about to alerting, you have to set up multiple alert managers, and alert managers will take care of deduplicating the alerts which are sent by both Prometheuses to them. So you don't have to worry about duplicated alerts and being waken during the night by 2 alerts instead of 1. But this setup has an issues. For example, if one Prometheus goes down, and you have like 2 Prometheuses, you don't fix it right away, you're waiting for after your morning coffee, you bring it up, and then one Prometheus has all data and the second Prometheus doesn't have like 12 hours worth of data, for example. So if the other Prometheus goes down, you kind of missing the data, historical data there. But it's fine. It's fine when you use it for monitoring. You still get alerting, and it's like reliable solution to work with. The problem could be with graphing. It's also for an issue when one Prometheus will scrape at, for example, at 3 o'clock. Another Prometheus will scrape at 3 o'clock and 3 seconds, for example. And you have like service A is generating a lot of requests and the metric is changing rapidly. So basically, if you query those Prometheuses in Grafana dashboard, you will probably get different looking graphs. So it might be a problem, but it's not a big of an issue, as you can just switch between instances of Prometheuses. Okay, but how to actually do it reliably? So in Grafana, you would need to do data sources to query Prometheus 1 or Prometheus 2. So if you'd like to have a global view on both Prometheuses at the same time and query the active one and don't want to to check which actually is down or not, you can do it. And which brings us to the subject of scaling Prometheuses. Once we have reliable solution that we know that metrics are there, Prometheus is running, and we know that we're gonna get alerted, we can care about scaling Prometheus. So imagine that we have this super nice installation of Prometheus, more team are onboarding, so we have more and more data, and imagine that service C from this previous graph decided to emit 100 times more data than before, 100 times more data series than before. So what we do, our Prometheus is kind of dying because they cannot ingest so much data. So the recommended way of getting around this problem is to create a separate Prom instance, which will be dedicated for scraping metrics for only this service. So it means that both Prometheuses we had before, they will still scrape 2 services, and the other service, which generates a lot of metric data, will have a separate Prometheus instance. What we do here is actually manually sharding the load across fleet of Prometheus instances here, but it's kind of tricky for a few reasons. At first, for example, when you want to graph a dashboard for all the services at once, it's not kind of possible. You have to switch between data sources because data for service A and service B are in 2 Prometheuses, and service C has data in another Prometheus. So you have to kind of remember which service stores data in which Prometheus. So it's getting pretty complicated, especially when you have bigger instance. So the solution here, when we are scaling in this way, is adding a new Prometheus instance, which is called federated instance. So this instance will scrape all the other Prometheuses and will allow you to have the aggregated view of the world. So you can query one single Prometheus instance to get the data for all services. It has its issues as well, as for example, when you add this instance after some time, you still have, for historical data, you still have to go to another Prometheuses, and you have to like juggling those data sources in Grafana or other dashboarding solution to actually get the data you are looking for. And when you're scaling for example, more data centers, more zones, is getting much complicated. So basically, you are ending up running like dozens of Prom instances, which are across all like zones or regions or data centers, and still you need to remember which Prom instance contains which data. Sometimes, if you're like trying to drill in to your metric you're looking for. Yeah, but this covers the scalability of Prometheus. It's possible. It might be a bit tricky and it might require some overhead from operations perspective, but it's doable. Another thing, we are like, as we have like reliable and scalable Prometheus solution, monitoring solution, we probably want to get more and more metrics, which also brings us to the next point, which is storage efficiency in Prometheus. So this is another story, as Prometheus doesn't give us like real downsampling, which means, for example, I'd like to store what I mean by downsampling in the first place. So, for example, when I have a metric comes to my metric system, I would like to store a raw data point with 15-second resolution, for example, for 5 days. But for historical reasons, I don't need this resolution. I could store every data point every 5 minutes and just store it for like 2 years, just to have like historical view of, I don't know, my CPU usage in the clusters or something like that. So in Prometheus, it's not kind of possible. It stores all samples, like raw samples. And the funny thing, and not funny, but like it could be also a surprise for some people, that the default retention when you start Prometheus is 15 days only. So if you need to store more metrics, you have to expand. You have to configure Prometheus to configure retention for a longer time. Of course, there's like you could get away with this issue by setting up another federated instance to store data with raw resolution. So basically, this federated instance will read the raw data from other Prometheuses every, for example, 30 seconds, downsample them and store them in this separate instance. But yeah, it also brings us another set of problems. For example, when you downsampling, when you create recording rules in Prometheus, you actually create a new metric with a new name. So if you have dashboards and you would like to look for a metric, look for a, I don't know, service metrics for one time period, like for example, week back, you would have different metric name than you would have like for data for past 1 week, for example, for a year. So it also brings us a lot of issues in this sense. Okay, but there has to be something what we can do about it. And the answer to all these issues with storage, long-term storage, mostly in downsampling, is the remote storage for Prometheus. So remote storage is a protocol which allows Prometheus to write data samples to remote third-party storage, which actually was designed for which was designed for storing the metrics for the long term. There are like few projects in this space. These are totally random, hopefully totally random project names here. One is Thanos, the other was Cortex, and the third one, of course, is M3, which I will be focusing on in this talk. They all offer the global query view, so you don't have to worry about which data is on which Prometheus instance and so on and so forth, or which metric should I use. They support downsampling and long-term storage. Okay, so let's talk about M3 a bit and monitoring with Prometheus M3 and how to use them both to achieve the possibility to have like hundreds of thousands, even like millions of metrics to be stored in your database and don't worry about reliability, scalability, and storage. So what is M3? M3 is an open source metrics engine. It consists of custom built time series database. It's optimized, and another part is optimized ingest and downsampling tier and optimized query engine. It was built in open source from day one at Uber, and it was proven at scale at Uber. It was like, I don't remember the numbers. I don't want to lie to you, but it was like billions of metrics stored at Uber. It's used by companies like Walmart, LinkedIn, and many others, and it's maintained by Uber and Chronosphere. We also use M3 internally at Chronosphere. The key features of M3 are, as compared to Prometheus, like M3 was built with simple operations in mind. That you don't have to, remember how to share manually data between multiple Prometheus instances, or when you service like one service start emit more metrics and you worry about disk space or like Prometheus instance, you don't have to shard this data and shuffle it around. Here, if you're running out of disk space, you just like add new M3DB node. So each of these tiers I mentioned they scale horizontally, and they as I mentioned, they're proven to store billions of metrics time series. The storage is reliable. If you install M3DB cluster, the default replication factor is free, which means that there are 3 consistent copies of all data stored in M3. It was when M3 was designed, it was designed to tolerate single node, zone, or even region failures out of the box. It supports multiple ingestion formats, Prometheus, Graphite, and InfluxDB, and you can query M3 data with PromQL and Graphite. So here is how it looks. Sorry. Here is how it looks when you deploy M3 in your system. So on the left we have Prometheus. Unfortunately, M3 coordinator won't scrape your metrics. You need Prom for that. So Prom on the left will scrape your metrics as usual, and it will use Prom remote write to write the metrics to M3 coordinator. M3 coordinator is the ingestion and downsampling tier. Then the M3 coordinator will store the data into M3DB, which is the actual database, time series database, which stores the metrics, called M3DB. And on the right, on the query side, we have Grafana here, which queries M3 query. This is the query tier, which fetches data from M3, and it shows the graphs in Grafana. Sorry. So this is like super simple architecture overview. As I mentioned, you still need Prometheus here, and Prometheus will scrape the data and write the metrics to M3 coordinator via Prom remote write. Okay, so let's dive a bit into different parts of M3. So let's start with the write path. So the Prom instance scrapes the metrics, writes them to coordinator using Prom remote write, and every data point which is written to M3 coordinator by Prometheus getting replicated 3 times in this example when you have replication factor 3, and gets written to 3 different places across the M3DB nodes. It uses the quorum write, which means that 2 of the 3 copies of the data point have to be successfully written in order to be called a success. And if it doesn't succeed to write this data, the coordinator will retry until it's called a success. The M3 coordinator is also in charge of downsampling here. So, for example, when a raw data point comes to M3 coordinator, the coordinator generates downsampling data inside itself. So instead, not only it's in charge of writing the data, raw data to M3DB, but it's also in charge of downsampling the raw data point. by creating larger tiles of the data. For example, you would like to have like 5 minutes average. The M3 coordinator will do that, and then it will use the same quorum right to write this downsampled data to M3. So actually, the downsampling here is done on the ingestion path, as opposed to writing all raw data to M3DB, then reading it in batch mode and aggregating it and writing it back to the M3DB. Okay, so excuse me. We got the write path covered. Let's jump into read path. So on the query side, the query engine, as I mentioned, implements PromQL and Graphite protocol with PromQL and Graphite. And what you do, you just like point that you don't need like Prometheus here on this side. You just like point Grafana or Alert Manager directly to your M3 query, and M3 query will fetch the data using quorum reads as writes as well. So what it means that it will ensure that at least 2 copies were fetched successfully to get your consistent read. Then it will apply all the functions which you would like to apply and return the data to Grafana or Alert Manager. So one thing worth mentioning here that M3 query is a stateless service. So basically you can put a load balancer in front of it and just point your Grafana or Alert Manager to a single point. And you can query any M3 query, and M3 query will return every M3 query will return the same results for your query. Because it will, like when you query using M3 query, it will gather matrix data across all query instances or all the M3DB nodes, and will return the consistent results to you. And what's worth to mention here is that M3 query is 100% PromQL compatible. So kinda it's like a drop-in replacement. If you have like a lot of queries or a lot of dashboards in Grafana, you can just point your Grafana dashboards to M3 query, and they should work basically. Okay, so let's jump into deployment of M3. So in this example, we have a super simple deployment. So as similar to the previous slide, we have like 2 M3 coordinators running. Let's imagine we have 3 M3DB nodes running, 3 M3 query runnings, and that's all. If we would like to scale this deployment, for example, we have more data and we would like to avoid failure of a single region within a cloud or something or data center, we would do the multi-zone deployment. Like we could run the M3 in multiple zones, for example, within a single region in your cloud provider. So here on this picture, we have 3 zones, zone A, zone B, zone C. So and how it works with M3 in here. So what we do, we spread out our M3 cluster across 3 zones. The coordinators, the M3DB and M3 queries are running in every zone. But in this setup, we have like 3 replicas of the data. Replica 0, replica 1, and replica 2. So in this case, 1 replica of all M3DB data will be kept in one particular node. So this is designed in case the AZ goes down. So for example, if zone A is totally gone, there is an outage in your cloud provider and it's gone, you will still have quorum reads and quorum writes because the data will be stored in replica 1 and replica 2. So you have 2 additional copies. So how the writes work? So the coordinators will write to all 3 replicas using quorum as well. And like the query works the same, it will query across all replicas, across zones using quorums as well. Of course, you can put a load balancer between Prom instances and coordinators as well between M3 queries and Grafana or Alert Manager. So yeah, still, if you lost in this setup, if you lost the whole zone, the cluster would still be up and running, and you still can write data and read data because you still have 2 of the copies of your data intact. So they maintain quorum, read and write logic. So it's perfectly fine and it's super reliable. So imagine that we have this setup, we have multi-zone deployment, we are super happy onboarding more services, getting into more regions in the cloud. and we decided to go to multi-region deployment. It's also possible with M3. So here I'm showing you the zoomed out version. So here we have like two regions, EU West 1 and EU East 1. So every region has 3 zones. So we have in every region we have multi-zone deployment, and in 2 regions we have those multi-zone deployments. So when we look across those 2 regions, the data is spread like the data. So we still write and read the data within a single region. So we recommend that for multi-region reliability, the data that is stored and produced in a particular region should stay in this region. So if you have services in region EU West 1, you should generally store this data in the same region. Just don't. It's like we don't like. It's not recommended to do the cross-region replication. First, it's expensive probably in the cloud environment, and there's like a lot of other issues with multi-region deployments in like all the services, I guess. So in this case, when we have multi-region deployment in M3, we do the same for writing, but for M3 query, the M3 query tiers are connected to each other in both regions. So basically, if I query M3 query, if I do issue a query to M3 query in region EU West 1, it will fan out the query to all the M3 queries also in other regions and return the data from all the regions. So basically, you will get the world view of all the regions you have. So for example, if I have my Grafana in region EU West 1, I query my local M3 query, but this query in one region will go to M3 query in the other region, will gather all the data, and will return me consistent results from across all the regions. Okay, so just to recap, with multiple regions, it's not recommended to replicate data across multiple regions. Store the data within the respective region and connect the query engines so they can fetch the data from different regions if needed. Okay, so I have a super short demo for you as well. So I'm running, what I'm doing here, I'm running 2 Prometheuses. So I have one Prometheus, as you can see, it's localhost 1990, second Prometheus, and I'm having a Grafana. So when we go to Grafana and query for some metrics, for example, metric up, run the query, and we have nothing. Oh, sorry. So we have Prometheus, one Prometheus here, Prometheus 1, which has some metrics. As you can see, it has some metrics, but it has only Prometheus 1 metrics as well. When we switch to Prometheus 2, it will have the data for Prometheus 2 as well. It's missing the data for Prometheus. Let me make it bigger, perhaps. One more time. If we query Prometheus 1, as you can see, it returns the data for M3 coordinator 1 and all the other instances, and it's monitoring itself. When we go to Prometheus 2, it has the data for Prometheus 2 only. It's missing Prometheus 1. So what we can do, how easy it's like to set up the remote write for Prometheus to write the data into M3DB. It's basically what we can do is just edit the configuration file for Prometheus. I have commented out here. Let's remove the comment. So what we're doing here, we are telling the Prometheus that, hey, here is the remote write, and every metric you scrape, just write to this endpoint. And this endpoint is the M3 coordinator endpoint I mentioned before, which supports the Prometheus remote write protocol. Okay, so we have this one for Prometheus 01, Prometheus 02. If you remove that, let's restart the Prometheuses. Okay. Let's get back to our let's limit the metric to Prometheus. Okay, so as you can see, in Prometheus 2, we're scraping only Prometheus 2 metrics. In Prometheus 1, we scrape only Prometheus 1 metrics. And imagine you have like dozens of those Prometheuses, and the metrics are shared manually, and you have to remember which Prometheus has your data. But if we switch to M3 query, which aggregates both of them, and both Prometheus are writing to M3 coordinators, we can see the aggregated data here. So we have both data points from Prometheus 1 and Prometheus 2 here. So this is as easy as it when you have your cluster. It's like enabling remote write protocol for Prometheus is like super easy. It's like a single change in configuration. Yeah, that's all I have for demo for you. And are there any questions? I'm not sure how we're doing questions today. Yep, I don't know if there's questions, so I will show you maybe. Let's go. Thank you very much for listening to me. And if you need more information, there are links for M3 website. If you have any questions about M3 or Chronosphere, M3, you can drop by M3 Slack. If you'd like to know more about Chronosphere, there's Chronosphere website. And that's all from me for today.
Okay, guys. So we will wait a couple of minutes. Maybe there is some questions. We will let you know.
Yep.
Yeah, Łukasz, we have a bit delay between the YouTube translation, so we can.
No worries whatsoever. Also, as I mentioned, if you have any more questions, you can always drop me an email or PM on Twitter. I'm always happy to answer all those questions.
So, Łukasz, we have first question from you. In which cases do you recommend to use Amazon Managed Service for Prometheus?
To be honest, I've never used Amazon Managed Prometheus, so I'm not the best person to ask this question. To be honest, like definitely like it's I think it's the same case with all the managed service, right? If you don't have like capacity in your engineering team to manage the service itself, maybe it's worth like buying something ready-made, right? But yeah, I cannot say anything about AWS Managed Prometheus. Although I can put a shameless plug here in the meantime, if you have issues with your Prom metrics as well, you can try to visit Chronosphere website and learn more about Chronosphere and what we could do for you about it as well.
So yeah, probably this is the last our question. So Yuri Stechniak said thanks to you.
Thank you.
So, okay.
Okay, thank you very much. So once more, if you have any questions, feel free to drop me an email on PM me on Twitter. I'm always happy to help.
So, okay, thank you for watching. Again, thank you for our partners Avangas, Sombra, and Grid Dynamics for supporting our community here at Lviv. Also, thank you for our community partner, JetBrains. Also, remember to fill the feedback form, and you will get a chance to receive 1 year free account on JetBrains. Also, for most active, there is one most active person, it's Yuri Stechniak. So congratulations, you will receive Bulочка and Cacao. Also join us. So thank you for watching. Bye-bye.